Hello student, welcome to the GATE Score Booster session of measurement. So I hope all of you are fine and taking a very good care of your health. So before proceeding to the session, uh, please share the session link with your friends so that they can join as soon as possible. All right. So meanwhile, let me check how many of you are here. Okay, so please share the session with your friends so that they can join as soon as possible. All right. So meanwhile, let me give you a brief intro about the session or the agenda behind the session. That is what we are going to do. So through this session, we will going to revise the syllabus of the measurement from electrical and instrumentation, from electrical stream and also from instrumentation stream with some good number of question. So please be ready with your pen and paper. All right. Okay. Guru Pratap Singh, very good evening. So I request you to please be ready with your pen and paper. All right. So in this session, we will going to cover the total of 4 questions. Means uh, first we will cover the question from error analysis. Then we will going to cover the question from the your basic instrument, which is voltmeter and ammeter. Then the third one is measurement of power, and your fourth one is bridges. So in total of 4, we will going to see 4 questions, and we will going to cover this 4 question with good number of concept and with good number of questions as well. All right. So good evening, Isha. So this session means the measurement session comprises of total of 2 parts. So this session is your first part, and the second part is on tomorrow from 6:30 a.m. Yes, you heard me right, from 6:30 a.m. to till 8:30. All right. So these are the brief intro about the session. So I request you again, so please share the session link with your friends so that they can join as soon as possible. All right. Now, who am I? So I am Nikhil Gaurav. I have done MTech from BIT Durg, which is in Chhattisgarh, and my specialization is on industrial drive and control, which is basically a part of power electronic. All right, and I have a 3+ year experience in gate domain, and I am a subject matter expert at the Gate Academy from power in power electronic measurement and as well as in control system. So these are some brief intro about me. So how many of you are excited here? Just say yes, sir. We can go to question. Everyone, can we go to go to the question right now? Okay. So let us move to the question number 1 for the today's session. So this is your question number 1. So the chapter is measurement of voltage and current, and this is MSQ question. All right. So please read the question very carefully, as this is very conceptual question, and this question is comprising of 2 subjects. First one is measurement, and second one, you can say that it is analog or power electronic. All right. So this is really a conceptual question. Please read the question very carefully, and if you want to give the answer, then option, then you can write it in the comment box as well. All right. So let us read the question first. In the given circuit, the ideal voltmeter are placed, one across capacitor and another across diode as shown. Then which of the following reading is are correct? So this is the circuit in which we need to find the voltage across the capacitor and voltage across the diode. Means which one of the following 2 options or which one of the following options are correct, which we need to find it. All right. So for that let me ask you one question. The voltage across diode is nothing but voltage given by MI. So what is MI? MI is moving iron instrument. So can anyone tell me moving iron voltmeter reads RMS or average value? Can anyone tell me that? Moving iron instrument reads what? It reads RMS value or average value? I didn't receive any answer. Please write in the chat box. Moving iron instrument read, Isa says average value. Uh, Isa, you are wrong. Please think again. Moving iron voltmeter. I am talking about moving iron voltmeter. So moving iron voltmeter reads RMS value. All right. It reads RMS value, whereas V2, which is voltage across capacitor. Yes, Suresh, it is RMS value. And the voltage across capacitor is voltage of a voltage given by PMMC. What is PMMC? Permanent magnet moving coil. And this will give average value. All right. So please remember, moving iron voltmeter gives RMS value and PMMC voltmeter or PMMC meter will give average value. So we need to find this voltage given by moving iron and PMMC voltmeter. All right. So first, let me copy this diagram, this circuit, so that it will be easy for us to derive the expression. Okay. So this is your network. All right. So for the sake of simplicity, let me remove this. All right. Let me remove this. Now, by looking this figure, we can say that this is a single phase rectifier. Am I right or not? By looking the figure, we can say that this is a single phase rectifier. But mind it, you are wrong. This is not single phase rectifier. All right. So let us analyze the circuit and let us find what will be the voltage across diode and what will the voltage across the capacitor. So let me take the current in the loop as I. In the loop as I. So during positive half cycle, during positive, let me take it as case 1. So during the positive half cycle, diode will get will going to be on or not? Everyone has to answer. Diode will going to be on or not? For diode this is anode part of diode, this is cathode part of diode. So whenever voltage of anode is greater than voltage of cathode, this is equal to VAK. If it is greater than zero, then your diode will going to be on. All right. And if VA minus VK or VAK less than zero, then your diode will be off. I hope all of you are knowing this point. All right. So uh, as I've already taken that during the positive half cycle means omega t varying from 0 to pi. Yes, it's a you are correct. Diode will be on during the positive half cycle. All right. So let me take it as VA and let me take it as VK. All right. All right. So the expression for the expression of VD will be, let me take it the supply voltage as VS and capacitor voltage as VC. All right. So the voltage across diode, this will be equal to VS minus VC. Am I correct it or not? Am I correct or not? Am I correct or not? Yes, I am correct. So Vs is nothing but Vm sine omega t minus Vc. All right. Now for diode to be on, this voltage is need to be greater than zero. All right. This voltage need to be greater than zero. Now what will be the current expression? What will be the current expression? Look here, look here. During the positive half cycle, this diode will be on. During the positive half cycle, this diode will be on. So can I say that 0 equal to Vm sine omega t minus Vc, and Vc is nothing but Vm sine omega t, which is nothing but supply voltage. So this is the expression for capacitor, and this is exactly equal to your sinusoidal voltage. All right, now let me find the current through the circuit. So current through the circuit, or current in the circuit, or current through the capacitor is given by 1 is given by C dVc by dt. Is it correct? Is it correct or not? So C is 1 into 10 to the power minus 6. Let me check. So capacitor value is 1 microfarad. All right. So 1 into 10 to the power minus 6 d by dt. So dv means Vc capacitor voltage is Vm sine omega t. So the differentiation of sine omega t is nothing but 1 into 10 to the power minus 6 into Vm cos omega t into omega. So I hope you are very well aware of sine omega t. So the differentiation of sine omega t is nothing but cos omega t. So the Vm, what is Vm? Vm is the amplitude of the voltage. So look here, the voltage given in the supply is 230 volt. The voltage given in the supply is 230 volt. So please answer me whether this is RMS value or maximum value. Please answer me whether this is RMS value or maximum value. Everyone, please answer whether this is RMS value or maximum value. Okay, one has answer. Rajesh, RMS value. Okay, Suresh, RMS value. Okay, both are correct. So the value given in the supply is nothing but the RMS value. So whenever, look, whenever V of t is given as V like 230 sine omega t. So whenever the amplitude is given with the sinusoidal, that means this will be maximum value. But here the sinusoidal term is missing. That means by default we have to consider as a RMS value. So the given value, that is 230 volt, is RMS value here. So the maximum value, will be given by Vm equal to root 2 times of Vrms. So root 2 into 230 volts. So this will be the maximum value of the supply. So 1 into 10 to the power minus 6 into Vm into omega. So let me take it together and let me name it as Im. So cos omega t. All right. So this is I equal to, means current through the capacitor is Im cos omega t, where Im is, or let me take as equal to, is root 2 into 10 root 2 into 230 into 1 into 10 to the power minus 6. Omega is 2 pi f is 50 hertz. So this is the maximum value of the current. All right. All right. Now what we need to do, we need to draw the waveform for the better clarity or the better understanding of the circuit. So let me copy this. All right. So Vs means supply voltage with respect to omega t. All right. So your supply is sinusoidal. So this will going to be vary in this fashion. All right. So this will be sinusoidal. Sorry for that. So this is sinusoidal, and All right. So this is 0 point, this is pi, this is 2 pi. All right. Now current. Current is varying cosinusoidally, means it will vary in cosine form. So at omega t equal to 0, cosine is maximum. So it will vary in this way. And it will reach here, where this point is pi by 2. All right. At pi by 2, cos value is what? At pi by 2, cos value is what? Everyone, please answer. At pi by 2, the value of cos is 0. That means the circuit current will be 0 at exactly omega t equal to pi by 2. And your capacitor voltage will follow this supply voltage. So it will going to follow supply voltage in this way. All right. So this will be maximum value. This will be maximum value, which is root 2 into 230. This is also root 2 into 230. And this voltage is nothing but capacitor voltage. All right. Now, what after pi by 2? What after pi by 2? So after pi by 2, the capacitor current will will be going into negative value, will going or will enter into negative value. All right. Negative value means the direction of current will going to be opposite. Direction of current will going to be opposite. Now look here in the circuit. I have assumed that the direction of when the diode is conducting, the direction of current is this. But after pi by 2, the current will trying to reverse itself. So it will going to be follow this direction. Am I correct or not? Am I correct or not? Yes. So it will going to be follow the opposite direction. Now, what is the meaning of this? The diode direction is this and the current direction is this, means both are opposite. So whenever the diode direction and the current direction both are opposite, then your diode will going to be off. All right, your diode will going to be off. That means when diode will going to be off, your circuit will look like this is supply voltage. So exactly after pi by 2, exactly after pi by 2, this will going to be your circuit. All right, this is plus minus Vd and this is Vs. All right, so exactly t greater than equal to pi by 2, your diode will going to be off. It is because the circuit current will going to be in negative. That means the direction of current will going to be reverse. So your diode will not going to allow that current. So diode will going to be open circuited. That means diode will be open and in circuit there will be no current, means I equal to 0. So that means after pi by 2, the current will going to be 0. All right. Now till 2 pi, supply voltage is anyhow negative. That means after till 2 pi, means after pi by 2 to till 2 pi, the current value in the circuit will be 0. All right. Now what will be the voltage of capacitor after pi by 2? Now look here, the capacitor is charged till Vm, till VL, means maximum value. Now after pi by 2, the circuit will not allow any current. That means the capacitor voltage will going to be clamped, at Vm. All right. So let me change the color. So after pi by 2, your voltage will going to be Vm. All right. All right. So if you are having doubt, please ask in the comment box. All right. Now look here. Let us find when will diode going to be conduct. When will diode again going to be conduct? So we have already found the value, the expression for Vd, which is equal to Vs minus Vc. All right. So Vs is Vm sine omega t minus. So at pi by 2, the value of Vc is Vm. All right. Now look here, from pi by 2 to till pi, from pi by 2 to till pi, the value of Vs will be less than Vm. All right. The value of Vs will be less than Vm. That means this value will be negative. This value will be negative. Means here diode is off. All right. From from pi by 2 omega t to till pi. All right. Now let us find during the duration pi to 2 pi. So the supply value is negative. Supply value is negative. So this will be negative and here minus Vm. So diode is again off as this value will be negative. So from pi to omega t till 2 pi. So diode will be off. So from pi by 2 to 2 pi, your diode will be off. Now let us come to waveform after 2 pi, means supply voltage after 2 pi. So after 2 pi, your supply voltage will going to be positive and it will increasing from 0 to till maximum Vm. So Vd equal to Vs minus Vm from omega t, this is 2 pi to, let us say, 5 pi by 2. All right. So this value is again negative. So your diode is off. All right. So what we can conclude here? We can conclude here that once the capacitor current decreases to zero, once capacitor current decreases to zero, then it will never going to be on. It will never going to be on. That means your capacitor voltage will clamped to plus Vm till infinity, till omega t equal to infinity. And what about the current in the circuit? It will going to be 0 till infinity. All right. Now let me draw the waveform for diode voltage. So at pi by 2, look here, at pi by 2, the voltage of the diode will be here. Just put the value of pi by 2. Sine pi by 2 is plus 1. So Vm minus Vm will be 0. So it will start from 0. At pi, it reach minus Vm, and at 3 pi by 2, at 3 pi by 2, it will be maximum. This is 3 pi by 2. All right. So this value will be minus 2 Vm. All right. Now after this, it will going to repeat itself. All right. So these are the supply voltage waveform. This is current in the circuit. This is waveform of the capacitor, and this is the voltage waveform across the diode. So now our next part is to find the V1 value and V2 value. So let me first find the V2 value. So V2 value is nothing but the voltage across the capacitor, which is given by permanent magnet moving coil. So the conventional formula, or you can say the basic formula for the average value will be 1 upon T, area over the integral T, voltage V of T dt. All right. So this is the conventional uh, formula for PMMC, or you can say that average value. So let me take one time period. So one time period will be 2 pi integration 0 to 2 pi. All right, integration 0 to 2 pi. So capacitor voltage after pi by 2, it is constant, and the value is plus Vm. So the capacitor voltage will be Vm and d omega t. So the resultant of this value will be Vm only. All right, so the resultant of this value will be Vm only, and the Vm value will be root 2 into 230 volt. All right, so this is the capacitor value, uh, which is root 2 into 230 volt. Let us go and check the option in which option we are getting this. So we are getting this in option B. So when you find the value of root 2 into 230, you will be getting the value as 325.22 volt. Now our next part is to find the voltage across the diode. So VD equal to VMI, and the basic formula for this is 1 upon T integration over T V of T whole square dt whole root. So this will give you RMS value. So you might be knowing this from your signal system. So the formula that I have used here is nothing but the formula which I have taken from signal system. All right. So 1 upon T V d of t whole square dt. So let me take one time period, which is 2 pi from 0 to 2 pi, or rather let us take the time period from waveform itself. So this is diode waveform. This is diode waveform. Your diode is waveform start from pi by 2 and it will end at 2 pi, and this is 2 pi plus pi by 2 means 5 pi by 2. So the time period for Vd of t is pi by 2 to 5 pi by 2, and the expression for diode is Vm sine omega t minus Vm. This is Vm sine omega t minus Vm whole square d omega t, and this is whole of root. All right, now let me take out the common Vm from the root. So this value will be Vm divided by root 2 pi. Now integration from pi by 2 to 5 pi by 2. Here sine omega t minus 1 whole square d omega t and whole root. All right. Now when you are going to solve this integration of expression, so when you are going to solve this integration form expression, you will going to get the value as Vm divided by root over 2 pi into root 3 pi. So please find the value of the integration. Definitely you will going to get root over 3 into pi. So the value for this is root over 3 by 2 into Vm. So this value will be root 3 divided by root 2 into root 2 into 230. So this is equal to root 3 into 230 volt. So when you are going to solve this, you will be going to get the answer as 398. All right. So let us go and check the option. So we are getting 398 in option C. All right. So the correct option for this question is option B and option C. All right. So if you are having doubt, please ask me here. If you are having doubt, please ask me here itself. All right. Otherwise, we will going to see the next question. Okay. So let us go and check the second question. So this question is from the error analysis, and this is MCQ type question. So please read the question very carefully. The question is, for the given network, the measurement inductor L1 and L2 have tolerances of plus minus 10% on their nominal values. If the bus current is 20 plus minus 1% RMS, the minimum RMS current through L2 considering inductor tolerances is. So what we are supposed to find? What we are supposed to find? We are supposed to find the value of inductor current. Which current? Inductor current through L2. Let me take it as IL2. All right. So I need to find, or we need to find the minimum value for this current. So let me note down some data from the question. So the data given in the question can be jotted down as, so tolerances in the inductor is given as L1 equal to 20 millihenry plus minus 10%. So whenever the expression is given in this form, the first term will be known as true value, and the second term is known as error. And error can be given in, or error can be represented in two forms. First in percentage form, and another one is absolute term. All right. First in percentage term, and another one is in absolute term. So here, as inductor is given in percentage form, so this is known as percentage form or relative form. All right. So suppose I want to know the absolute value of L1. I want to find the absolute value of L1. That means the true value will be as it is, which is 20 millihenry plus minus. So 10% of 20 millihenry is what? Everyone has to answer. 10% of 20 millihenry is what? Please answer, guys. I'm seeing that you are not responding. Please, guys, respond so that uh, I can give more number and more number of concept and all right. Okay. So please guys respond. The 10% of 20 millihenry is what? So 10% of 20 millihenry is 2 millihenry. So this is in absolute term. So please keep in mind, whenever the error are in percentage, then we name it as relative form or relative term, or whenever the values are of the whenever the values of error are given in like unit term, then we will name it as absolute term. So the L1 value is varying from 20 millihenry minus 2, which is 18 millihenry, to 20 plus 2, so 22 millihenry. So these are the limit of your inductor 1. Similarly, the L2 value will be given by 5 millihenry plus minus 5 millihenry plus minus 10%. So this value will be equal to also 5 millihenry plus 10% of 5 millihenry, means 0.5 millihenry. So the limit for L2 will be 5 minus 0.5 millihenry, means 4.5 millihenry, and it will vary till 5 plus 0.5, means 5.5 millihenry. So the minimum value of L1 means L1 minimum is what? 18 millihenry, and L1 maximum value is what? It is 22 millihenry. Similarly, here L2 minimum is 4.5 millihenry, and similarly L2 maximum is what? 5.5 millihenry. All right. So what other information we have? We have bus current. So bus current is given to us as I bus. This is equal to 20 ampere plus minus 1%. Let me check. So this is 20%, 20 ampere plus minus 1%. So this will be equal to 20 ampere plus minus 1% of 20 means point 0 0.2. This will be 0.2. All right. All right. So just find the 1% of 20. You will get this value. Now let us come to the circuit diagram and let us find the expression for IL2. So just use the current division rule here. Just use current division rule. So IL2 value is nothing but the total voltage in the circuit, which is I bus into opposite inductance or opposite resistance. So here we have used inductance, so we will use opposite inductance. Means the current which I supposed to find here is here, which is in L2. So I will take L1 value in numerator divided by total inductance, which is L1 plus L2. All right. Now I need to find the minimum value for this. So let me note it down here. I L2, this is equal to I bus into L1 upon L1 plus L2. So can I write it as I bus into 1 upon 1 plus L2 by L1? Guys, please respond. Can I write it this or not? In this way or not? Yes, I can write it. So IL2 minimum, IL2 minimum. So when we when we are supposed to get this minimum value, if I bus will be minimum into 1 upon 1 plus L2 maximum divided by L1 minimum. All right. So the minimum value of the bus is, look here, 20 minus 0.2 ampere. That means 19.8 ampere. And 20 plus 0.2 ampere. This is equal to 20.2 ampere. So minimum value is 19.8. So 19.8 ampere into 1 upon 1 plus. So L2 maximum. Let us check the L2 maximum value for L2 is 5.5. So this is 5.5 millihenry. Millihenry divided by L1 minimum. So minimum value for L1 is 18 millihenry. This is 18 millihenry. All right. So when you are going to solve this expression, you will going to get the value as around 15.2 something. So you will be going to get the L2 minimum value as 15.2 ampere. So the correct option for this question is option D. All right. Now let me take this question one step ahead. Suppose if the question were about of finding the maximum value, then we have to take I bus maximum value into 1 upon 1 plus L1 minimum divided by L2 maximum. So with this expression, or by substituting the value of I bus, L1 and L2, you will going to get the IL2 maximum value. All right. So for this question, the correct answer is 15.2, which is given in option D only. All right. So the correct option for this question is option D. All right. So guys, please respond. Are you having any doubt? Are you having any doubt? Please respond, guys. Okay. So let us go and check the next question. All right. Let us go and check the next question. So question number 3. Here we take question number 3. So the question number 3 belongs to measurement of power, and this is MCQ question, means multiple choice question. So let us read the question very carefully. All right. The current coil, means CC, the current coil of a dynamometer type wattmeter is connected to Vs of t, which is equal to 50 sine 314t volt in series with 10 ohm resistor. All right. In series with 10 ohm resistor. The PC is connected through a rectifier in series with 50 Hz source of 200 volt. The inductance of the pressure coil is negligible. The reading of the wattmeter is. So this is the circuit which is given to us, and we need to assume certain assumption. Like see here, the assumption is assume the resistance of the diode as 5 ohm and the cut-in voltage as 0 volt. Means if this is my diode, then during on condition, the voltage of diode will be on with a resistance of 5 ohm. All right. So this is during on condition, but during off, we can assume is at open circuited. All right. So this is the assumption we need to do here. So let us check and find the solution for this. All right. All right. Now see here, your current coil and your pressure coil, your current coil and your pressure coil are supplied by two voltages, are supplied by two supplies. All right. So this question is somewhat is different from your conventional question. All right. So here current coil is supplied from is uh, is uh, is activated from the uh, uh, another voltage, and your pressure coil is going to be activated by another voltage. All right. So uh, so we will analyze the circuit by taking current coil separately and pressure coil separately. All right. So by taking the current coil circuit only, this is current coil, here resistance, here supply voltage. All right. So this is 10 ohm. This is current coil. This is Vs of t. And you know that the resistance of the current coil is ideally zero, means RCC is nearly equal to zero. So what will be the current flowing in the circuit? So current I will be given by Vs of t divided by 10 ohm, and Vs of t is already given to us, which is 50 sine 314t. 50 sine 314t divided by 10 ohm. So this value will be equal to 5 sine 314t. So can anyone tell me what is the frequency here? What is the frequency of I, or the current frequency? So the frequency for current I is given by omega equal to 314, and we know that f equal to omega upon 2 pi. So 314 upon 2 pi, this is equal to 50 hertz. So the frequency of the current is nothing but the 50 hertz. So this is the current waveform. So let us current expression. So let us draw the waveform for current coil current. All right. So let me name it as ICC. So ICC. So during positive half cycle, this will going to follow this. All right, where maximum value is plus 5 from 0 to pi. All right. Now after pi, your value will going to be negative till 2 pi. This is omega t axis. All right. So maximum value in positive is plus 5, and maximum value in negative is minus 5. So your ICC current, your current coil current is varying in this fashion. Now let me take the pressure coil circuit separately. So your pressure coil circuit separately will be look like here. Let me draw first. This is supply of the pressure coil circuit. Here we have one diode. Here we have one diode, then resistance, then we have another diode, then circuit will going to be closed. All right. And the supply given to the pressure coil whose amplitude, whose RMS value is 200 volt. So the maximum value is nothing but root 2 into 230, 220. I guess it is 220. All right. It is 200. Sorry, it is 200. Sine. So frequency will be same here. Frequency will be same. Otherwise, your circuit will not function. So we need to take the same frequency in the current coil as well as in the pressure coil. All right. So the resistance of the pressure coil is given to us, which is 5 kilo ohm. So let me take the current here as IPC. Now during on condition, your diode resistance is 10 ohm. Here this is also 10 ohm. So the circuit current, which is IPC, is root 2 into 200 sine 314 t volt whole divided by total resistance in the circuit. So total resistance in the circuit is 10 plus 5 kilo ohm, which is 5000 plus 10. So this will be root 2 into 200 sine 314 t divided by 50. Sorry, this is, I guess 5 is given to us. Yes, the diode resistance is 5. This is 5 and this is 5. So really sorry for this. So IPC. Now VPC, the voltage across the pressure coil. This is IPC into RPC. So the current expression is root 2 into 200 divided by 5010 into RPC is 5000 into sine 314 t. All right. So let me take it as V dash sine 314 t volt. All right. Now let us draw the waveform for this. Let us draw the waveform for the pressure coil voltage. So this is omega t. This is VPC. This is also follow sinusoidal curve from 0 to pi. This will be maximum. Then from pi to till 2 pi, it will be negative. All right. So we have got the waveform for ICC as well as for VPC. This is VPC. And we know that the reading of wattmeter reading, that is W, is given by integration over one time period from means integration over the time period 1 by t VPC of into ICC of t into dt. All right. I hope you are knowing this formula. Means wattmeter reading is given by voltage across the pressure coil and current through the current coil with area over the integral or integration over the one time period. All right. So look here. This is current waveform na ICC. Let me draw it once again. This is omega t, and this is your ICC current. This is ICC current coil current, where this is maximum value, which is 5, and this one is minus 5. All right. So I need to take the product of this two element, which is VPC of t and ICC of t. Now come to figure, come to VPC circuit, come to VPC circuit. Now during the positive half cycle, your diode will going to conduct, but during the negative half cycle, whether your diode will going to conduct or not, no, it will not going to conduct, as direction of current will be negative. So during negative half cycle, your capacity, your pressure coil voltage will be 0. Your pressure coil voltage will be 0. All right. So this will be 0 till 2 pi. Now after 2 pi, again the cycle will going to be repeat. So this is 2 pi. All right. Now see here. Let me take one time period. So 1 upon 2 pi integration 0 to 2 pi. So from 0 to pi, we have voltage, we have current, means we can multiply these two. So V dash sine omega t into 5 sine omega t d omega t. All right, from 0 to pi. All right. Now, what about pi to 2 pi? What about pi to 2 pi? Look here. From pi to 2 pi, the voltage, the pressure coil voltage is 0, and the current coil uh, and the value of current coil is non-zero, but the product of these two will be 0. So I can say that from pi to 2 pi, this expression will be nothing but d omega t. All right. So as the voltage is 0 from pi to 2 point, from pi to 2 pi, so we need not to take this integration. So wattmeter value will be equal to W 1 upon 2 pi into V dash into 5 integration 0 to pi sine square omega t, where omega is 314. So d omega t. All right. So V dash is what? V dash is root 2. This is your V dash value. Root 2 into 200 into 5000. Root 2 into 200 into 5000 divided by 5010 into 5 divided by 2 pi. So integration 0 to pi. I hope you are knowing this. Cos 2 theta equal to 1 minus 2 sine square theta. So sine square theta is equal to what? 1 minus cos 2 theta divided by 2. So 1 minus cos 2 omega t divided by 2 d omega t. All right. So if you are going to solve this expression, you will going to get the value as 352.8 volt. 380, 380, sorry, 352. Let me check. 352.8 volt. So guys, please find the integration for this. I am pretty much sure that you will definitely going to integrate uh, this expression, and you will going to get the value as 352.8. So rest part is your, please do the integration for this. All right, so this value is nothing but 352.8 watt. All right, so the correct expression, the correct option for this question is option B only. All right, so I hope the concept which I have discussed here is really beneficial to you. So if you have any doubt, please type in the comment box. If you are having doubt, please let me know and please type in the comment box. Otherwise, we will go to next question. Okay, so let us move to next question, that is question number 4. So the question is from measurement of bridges, and this is MSQ question. All right, so please be attentive. This question is MSQ, means more than one correct option are possible here. So please read the question. An unbalanced AC bridge, an unbalanced AC bridge is shown in the figure. What maximum voltage in magnitude can appear across detector for, or let me increase the font size for this. Okay, now I think this is comfortable for you right now. All right, so the question says an unbalanced AC bridge is shown in the figure. What maximum voltage in magnitude can appear across detector for X minus 1.5 to 1.5, where double colon is belongs to. So this is the range for X, which is varying from minus 1.5 to 1.5. And what we are supposed to find? We are supposed to find the maximum voltage across the detector. So this is our detector, and we need to find the maximum voltage. So let me draw the figure again here. This is your capacitor. This is your detector. This is again one your capacitor whose value is C1 minus X. Here it is C. Here it is C1 plus X. Then here it is C, and this is your detector. This is, which is VD, and one supply, which is E, and whose value is given to us as E equal to 1 sine 314 t volt. Okay, now see here, we need to find the detector voltage or maximum value of the detector. All right, so how to find this? So for this, let me take the current flowing in the circuit is I. Now when it reaches the junction A, it's going to divide in two parts, I1 and I2. All right, so I have shown here that your detector is open. It is because no information is given about, or you can say that no information is given about the detector, whether it is ideal or whether it is practical. So as we have no information about the detector, so we will assume it as an ideal detector. And you know that for the ideal detector, the voltage, the resistance for the detector will be infinite. So for that reason, I have shown as open circuited. All right, so once it get open, or once I assume it is open. So this current I1 will going to flow into into C1 minus X element also. Sorry, this is I1. All right, and I2 will going to here as well. So this value is C. All right. Now look very carefully. This node, let me take it as B. This at, or let me change the color itself. This is A point. This is B point. This is C. Or rather, you can say that it is a node. So A, B, C, D. These are the node. So can I say that voltage across A to till C, that is VAC, is nothing but E? Similarly, all right. So voltage across A and C, this is equal to E. So VAC is nothing but VA minus VC. All right. So, all right. Please, guys, respond. If you are having doubt, please let me know. Okay. So VAC is nothing but the voltage of the supply voltage, which is VA minus VC. Now, how to find VD voltage? So let us use KVL here. Let us use KVL here. Plus minus VD. The current is entering in this fashion. So first plate will be positive, and the later plate will be negative. Similarly, here current is entering in this way. So I will take it as positive, and here I will take it as, sorry, extremely sorry. The current is here I2 na. So I will take positive sign here and negative sign here. All right. Now let us use KVL. So let me name voltage plus minus VC1, and here plus minus VC2. So KVL will be plus VC1 plus VC1, then plus VD, then here minus VC2. Look here, while traveling in this direction, while traveling in clockwise direction, my first terminal in VC1, is positive. So that's why I have taken plus sign here. Now in this, sorry, when I reaches in VD, my first terminal is positive. So that is why I have written plus D. Now once I reaches VC2, my first terminal will be negative. So that's why I have taken negative sign here. So VD will be VC2 minus VC1. All right, is it clear or not? Is it clear or not? So the expression for VD is VC2 minus VC1. All right. So before coming to this expression, let me talk. Let me give you some important concept here. Let us say this is capacitor 1, and let us take this as capacitor 2. All right, and this is voltage plus V. This is overall voltage. So what will be the voltage across the capacitor 1, VC1? So to find the voltage of capacitor 1, we use voltage division rule. So total voltage into opposite capacitor, opposite capacitance, which is equal to C2 divided by total capacitor value, which is C1 plus C2. So in this way, you will going to use uh, voltage division rule to find the capacitor voltage in series, to find the capacitor voltage in series branch. All right. So VC2, this is equal to VC2. This is equal to total voltage is E into opposite. Look here. This branch is in series, na? This branch is in series. So I can use this concept. So E into opposite is C, opposite capacitor is C, divided by total capacitance, which is equal to C plus c times of 1 plus x. All right. So this value is equal to e upon 1 plus x. This is nothing but e upon 2 plus x. All right. Now, next we will find the value of VC1, voltage across the capacitor 1. So this is your capacitor 1. So this will be equal to, E into opposite is C 1 minus X divided by total capacitor in series. So C plus C times of 1 minus X. So this value will be equal to E 1 minus X divided by 2 minus X. So we have got the expression for VC1 and also for VC2. Let us substitute in VD. So VD will be equal to, VC2, which is E upon wait. So E upon 2 plus X minus E times of 1 minus X whole divided by 2 minus X. All right. So let us take out E as a common. So this will be equal to 1 upon 2 plus X minus 1 minus X upon 2 minus X. So let us simplify this expression. This will be equal to E. So 2 plus X, 2 minus X. So by taking the LCM, we will get 2 minus X here, then minus 1 minus X times of 2 plus X. All right. So this value will be equal to, or this expression will be equal to E times of this will be 2 minus X minus 2, then plus X square. And in denominator part, we are having A plus B, A minus B. So A square minus B square. So 2 square minus X square. So the resultant expression will be E times of 2 will going to be cancelled out. X is also going to be cancelled out. So here we will have X square divided by 4 minus X square. So this is expression for, so this is the expression for, this will be the expression for your diode. All right, this will be the expression for your diode. Now, how to find the maximum voltage of the diode? So to get the maximum value, or to get the maximum of any function, what you are supposed to do? You are supposed to differentiate that function. Let me take an example here. Suppose you have expression f of x equal to x square plus 2x minus 1. Suppose you have a function like this, and I ask you that please give me the maximum value for this function. Please give me the maximum value for this function. Then what you will do? You will differentiate this function with respect to x, and you will equate it to 0. Then after that, you will have some root. Let me say at x equal to x1. So exactly at this value, you will substitute at x equal to x1 in function f of x, and you will find the value as x1 square plus 2x1 minus 1, and you will tell me that, sir, this will be the maximum value for this function. So this concept I am going to use in my VD expression. So let us differentiate. Means for obtaining the maximum value for any function, you will have to differentiate. So differentiate VD with respect to what? With respect to E or X. We need to differentiate with X only. It is because X is the variable. As X is varying from minus 1.5 to 1.5 now, so this is my variable, but E is constant. So we need to differentiate with respect to X only. So derivative of VD with respect to S is nothing but d by dx of E x square upon 4 minus x square. So as e is constant, so I can take it out as a common from derivative. So d by dx x square upon 4 minus x square. So let us uh, differentiate this. E times of e times of, so x 4 minus x square into differentiation of x square is what? 2x minus x square. Differentiation of 4 minus x square is what? 0 minus 2x. Then whole divided by 4 minus x squared, the whole square. So this is your differentiation. So let us simplify more. So e times of, so e times of 8x minus 2x cubic minus this will be plus 2x cubic. So whole divided by 4 minus x square whole square. Now we will going to equate it to 0. We will going to equate it to 0, or rather let me write it, or let me simplify it as e times of 8x whole divided by 4 minus x square the whole square. It is because this will going to be cancelled out. All right. Now, when you are going to equate this to be 0, you will get x root as 0 only. You will get the root of x as 0. So this is known as saddle point. This is known as saddle point. So let us find the value of VD at x equal to 0. So the expression for VD is E x square upon 4 minus x square. So E times of x square upon 4 minus x square. So this value will be 0 at x equal to 0. So you may say that, sir, my answer or the correct answer will be C. But my dear friend, this option is wrong. But my dear friend, this option is wrong. It is because whenever, please listen me very carefully. It is because whenever the range is given to you, then you were need to find, or you have to find the value of the function at extreme point as well. Here the extreme point is x equal to minus 1.5 and another extreme point is plus 1.5. So you need to find the VD value at this point also. All right. So whenever range or limit for a function or the limit for x is given to you, then you were supposed to find the value at that extreme point as well. So VD at x equal to minus 1.5. So minus 1.5 is extreme point. So VD value will be E. E is nothing but 1 sine 314 t into x is minus 1.5 whole square divided by 4 minus 1.5 whole square. So when you are going to solve this, you will going to get the answer as 9 by 7 sine 314 t volt. Similarly, VD at x equal to plus 1.5. This is also the extreme point now. So please find the value of VD at x equal to plus 1.5 also. So 1 sine 314 t times of 1.5 plus 1.5 whole square whole divided by 4 minus plus 1.5 whole square. So if you are going to solve this, you will going to get the answer as 9 by 7 314 t volt again. All right. Now what to do after this? So after this, you need to compare all the three value, means at x equal to 0, at x equal to minus 1.5 at x equal to plus 1.5. So at x equal to 0, VD value is 0, and at x equal to minus 1.5, the maximum value is 9 by 7, and at x equal to plus 1.5, the maximum value is 9 by 7. So whichever value is maximum in this limit or in this value, whichever value of VD is maximum in this value, that value will going to be your answer. But anyhow, at x equal to minus 1.5, at x equal to plus 1.5, both value are same, and it is greater than 0. That means the maximum value for VD is 9 by 7. All right. So the correct answer for this question is 9 by 7, which is given in option D. All right. So the correct option for this question is option B. Now let me give you some important concept here. Now suppose your range, let us say your range for x is minus 1.5 to, let me take as 2, and at x equal to 2, you are getting the value as 10 by 7. You are getting the value as 10 by 7. All right. Now you need to compare these three value. Now you need to compare this three value. This is extreme, and this is saddle point. So you need to compare these three value, and out of these three value, whichever value will be maximum, that value will going to be your answer, or that option will going to be your correct option. So in this 10 by 7 will going to give you the correct option. But anyhow, the question is such that at 1.5 or at minus 1.5, the value of voltage both are same. So the correct or the maximum value for the diode will be, sorry, not for diode, the maximum value for the detector will be 9 by 7 volt, which is given in the option B, which is given in the option B. All right. So guys, if you are having doubt, please let me know here. Guys, if you are having doubt, please let me know. Sir, I have doubt in question number 1 or like question number 2, 3, and 4. So whatever doubt you are having, please let me know here. Okay, so it seems that you are not, no one is having any doubt. So I am assuming that all the concept that I have discussed here is clear to you. Okay. So with this, we have covered the fourth chapter. First, error analysis. Second, your basic instrument means measurement of voltage and current. Then third one is your measurement of power, and your fourth one is bridges. So with this, we have completed the fourth chapter. All right, and the remaining we will going to cover on tomorrow, and the tomorrow session is on morning. The timing is from 6:30 to 8:30. All right, from 6:30 to 8:30. So with that note, let me end this session. All right, let me end the session. So guys, if you have liked the session, so please like and subscribe our channel, and please share the session link with your friends, so that they may also get benefit from this session. And please subscribe our Hindi as well as English channel, and also press the bell icon to get the instant notification of all videos. All right, so thank you guys, and we will see you on tomorrow. All right, thank you.